Welcome to everyone listening to the Aerospace Ambition Podcast. This is Marius, alongside my co-host Kieran. As aerospace engineers, we navigate the crossroads of sustainable aviation and AI. In this episode, we delve into how airlines view the mitigation of non-CO2 effects. We're excited to have a special guest with us to explore this subject further. Kieran, could you introduce our special guest today?
Today we're joined by Dr Alejandro Block from the International Air Transport Association, or IATA, at which he is the manager for new energies and technologies, and he was in charge of delivering IATA's net zero roadmap. He has a PhD in aerospace propulsion and is a research visiting fellow at the Cranfield University. He is also a member of the Royal Aero Society and has authored several international publications on the topic of aviation emissions and the environment. With that, let's welcome Alejandro on the show.
Hi, Alejandro.
Hi, Marius. Thanks, and thank you, Kieran, for inviting me.
It's great to have you. And we've met last year in Madrid at the World Sustainability Symposium that IATA hosted. And so the first question, obviously, for our audience would be, what is the role of IATA? What are its goals, and how does it work together with the entire ecosystem?
Yeah, that's a good question to start. So we are an airline trade association. We've got about 300 airline members, and we do a lot of things for the airlines. So we create standards and recommended practices for many things, sustainability being one of them. So we have a sustainability certification, IENVA, and our airlines can sign up for that. So, for example, we will tell airlines best practice to monitor waste or plastic use or water use, etc. That's on some of the sustainability activities. We also have manuals for cargo, for dangerous goods handling, for checking in. So a lot of the things that you do when you take an airplane will be passing through standards or practices that IATA will have recommended. And then we also represent the airlines in the United Nations. So in ICAO, the International Civil Aviation Organization, which is the United Nations body for aviation. The airlines are represented there by us. So yes, quite a lot of things. On the transition to net zero emissions, we set strategy, we help our airlines understand the things that they can do. We engage with manufacturers, universities, OEMs, the United Nations on trying to see how we can scale up alternative fuels and new technologies to bring airlines to net zero by 2050. Yeah.
All right. That will bring a very interesting perspective to our podcast for sure. You moderated at this event that I've just mentioned last year. You've moderated the panel discussion together with Mark Stettler from Imperial College and also Florian Allroggen from MIT. A very insightful panel discussion, very differentiated viewpoints and also interactive. And this just leads me to the question, if you enjoy these kinds of panel discussions and these kinds of occasions, because it was really interactive and very engaging.
Yeah, thank you. I'm glad that you liked it. And I really enjoyed it. I think also speaking to Mark and Florian is always great, both in a personal level, but also having them on a panel. I think their perspectives were very interesting. I think that the non-CO2 scope or space is very cluttered by different ideas and opinions and so on. So being able to get two experts to talk a little bit about the science was actually very, very good and very insightful. Yeah.
Do you reckon that this year at the next WSS event in Miami, there will be a similar amount of attention be given to the topic of contrail management or non-CO2 effects, or rather more or less?
I think that perhaps just the same or more. I think it is an increasing area of attention and concern. There is more and more information, more and more people are getting interested in the topic, more and more people want to get educated on the topic. So at the moment, I only see it on the rising.
And you mentioned that IATA is highly involved in the pursuit for net zero aviation. Just wondering if you think that, well, if you could explain what net zero is and whether you think it goes far enough to really tackle the issues we face with aviation sustainability.
So at the moment, our commitment is for net zero CO2 emissions. So it's important to clarify that it's not net zero all emissions; it's CO2. CO2 is definitely our biggest enemy at the moment. CO2 emissions last in the atmosphere for hundreds or thousands of years. So you, me, and everyone listening will be long gone, and our CO2 emissions will still be there for the generations of our kids and grandkids and those. So it is very concerning. So our number one priority is CO2 emissions. Taking a decision to get to net zero is a huge challenge. So I do think that our challenges are going far enough at the moment, because just doing that is very, very difficult. I think we need to keep laser focused on tackling our CO2 emissions as a first priority. What net zero CO2 emission means is it basically means we will try to reduce as much CO2 emissions as we can on the source. And we do that by flying more efficiently, both with aircraft technology and operations. So we use less energy and thereby consume less fuel and thereby produce less CO2 emissions. Um, we also substitute our fuel on existing aircraft with fuels which are carbon neutral in nature, so or semi-carbon neutral. So these are fuels that will, over their life cycle, would have absorbed a very similar quantity of CO2 as they emit when we burn them. So over the life cycle of that fuel, that CO2 will be compensated. We are also exploring solutions where we will fly without emitting any CO2. So aircraft that can fly on hydrogen, electric aircraft for the very small range and very short passenger capacity, but it's part of the solution. And then we will have residual emissions. So we will not be able to tackle everything with this, and those residual emissions we'll need to capture back through credible offsets or carbon capture. So that is what net zero means. It means that on average, we're not putting any more CO2 into the atmosphere, and whatever we're putting is being compensated elsewhere.
So out of the solutions that you just described, which of those, if any, do you think are going to be most important for the next decade or so of action?
I think all of them. There is, so if you look at our net zero roadmaps or strategy, sustainable aviation fuels account for a very large part of it, so the majority. But I think that we need to fight on all fronts. And if we manage to reduce the energy use in flight by 7%, that is a lot less fuel we need to produce and burn. So that is just as that is just as important as producing a sustainable fuel. At the same time, doing progress in SAF doesn't mean that we have to delay any progress on flying on zero carbon emissions. I think that will have to be the end goal for many applications, to actually remove the CO2 from the operations. So we need to advance this as fast as possible. So I don't think that there is, I mean, I wouldn't say, yeah, they are all complementary. That's what I'm trying to say. I don't think it's one or the other. The focus is on everything because they are all interconnected and they all affect each other.
Sure. So what are IATA's views on including non-CO2 effects in net zero aviation, or moving towards, as Nikhil from Roland Berger said, about true zero aviation, so CO2 and non-CO2?
Yeah, I mean, we in our roadmaps, we in the introduction of our roadmaps, we acknowledge non-CO2 emissions, contrary to what Roland Berger said, because they said IATA doesn't mention non-CO2 emission, because we are mentioning that in the very first introduction part, we mentioned that non-CO2 emissions should be tackled as well. We also have a non-CO2 emissions position paper out there, so some of the comments on that report are a little bit misleading, or misinformed rather. But definitely, I mean, flying on absolutely zero emissions, honestly, it's going to be very difficult, right? Because when we talk about non-CO2 emissions, what are we talking about? We're talking about water vapor. We're talking about NOx emissions. We're talking about SOx. So there are some that we can tackle a bit more easily than others. So SOx emissions comes from sulfur in the fuel. Low sulfur fuels or sustainable aviation fuels or hydrogen will tackle that. So that, okay, fine. NOx emissions come from the combustion of the fuel at high temperature. They have nothing to do with the actual fuel. They have something to do with the high temperature processes. So those we can mitigate by better combustion technologies, by using electric airplanes, hydrogen airplanes with fuel cells, Even combusting the hydrogen on a jet engine will reduce NOx emissions, but it will not eliminate them, right? So we can reduce them, but it's going to be very difficult to fly through zero NOx. Water vapor, even if you replace it with hydrogen, we will have water vapor. So it's going to be very difficult to get rid of the water vapor. And then the secondary effects like contrails, and I think we will speak more about this. This is something that we are actively researching. There are a lot of airlines that are doing trials. Today, we've got 4 or 5 airlines or more that are doing different trials. Can we avoid these regions? Can we do this? We at IATA are investigating sensors. So there's a lot of initiatives going on. There are research projects that are involving airlines, OEMs, the scientific community. So it is a very active area. We cannot put right now a target on non-CO2 because it is very complicated. I think we will speak more about that, but it definitely is in our priorities to be able to reduce non-CO2 emissions as well.
Regarding the avoidance of contrails, how does IATA view this? Is everyone at IATA of the same opinion, or is there a spectrum of opinions?
No, I think that so we have a position paper. It's on our website. And on that position paper, we are acknowledging as IATA, as an organization, that non-CO2 emissions and contrails are on average warming, that it is an issue. We don't want to be putting stuff there that it's warming. So it is sort of widely recognized. Now, when it comes about avoiding, it becomes a bit tricky. So I think we can all agree that it would be great to avoid contrails. In theory, that's a good idea. Yeah. Particularly if we manage to solve some things, but the thing where we are a bit concerned about is all the gaps that still exist to be able to do this. And I will enumerate a few of them, right? So, for example, if you want to avoid a contrail, first of all, you need to know if that contrail is going to be very warming, very cooling. It doesn't matter. This is very hard to do today. A contrail is a cloud. So to be able to assess the climate impact of a single cloud, it is very difficult. It doesn't matter if the cloud was made by an aircraft or if it's a natural forming cloud, or weather systems or models are not that accurate, and the uncertainties are very, very large, right? So it's so okay. That's one point. Second point is we need to be able to know exactly where that contrail will be created. And this is also challenging. We know we can predict contrail prone areas. This has been done for many years, and it's possible. But those areas are very large, and they are not representative of reality. So I will give you an example. Maybe I'll give you a couple of analogies. So one is you can tell, okay, more or less over Bavaria, Munich, there's going to be contrails created with high likelihood. Okay, fine. But when we look at in situ measurements from aircraft that are flying with sensors, we see that the contrail prone areas are about 150 kilometers in horizontal extension. So we are predicting an area of 1,000, 2,000 kilometers where we say maybe a contrail will be created. And sure enough, if you fly through the middle of that area, you might create a contrail. But those areas are much, much, much smaller. So if we want to make this operational, we really need to improve on our capacity to model where these areas are. So an analogy is like the weather forecast might tell you, it will rain today. And sometimes they get it wrong, but it will tell you it's going to be cloudy, it's going to rain at about 11 a.m. But it will not tell you there's going to be a cloud over your house today at this time. We don't have that resolution, right? So, and this is for clouds. A contrail is a cloud. So we are improving on these models. There is a lot of progress, but there's still a lot of work that has to be done to be able to do avoidance in an operational way. Experimentally, we can do it. We can fly an airplane through a prone region. We can generate the contrail. We can see it. But one thing is experiments. Another thing is operationalize it. And we need to differentiate between these two.
Right. One takeaway from the panel discussion in Madrid was that we need more collaboration between the scientific community and industry. Where do we stand there today? Where is it working great, and where could we improve?
Yeah, so it is definitely. I mean, in IATA, we are not climate scientists, so we're talking about contrails, very highly difficult topic. We're talking about microphysics of clouds and radiative forcing of individual clouds. It's very difficult. We cannot do it on our own. So we are actually collaborating at the moment with many institutions. So the MIT, Steve Barrett, which you spoke to, we're collaborating with Imperial College, with Leeds University, with the World Meteorological Organization, with the OEM, so Boeing and Airbus. So this is definitely the first thing that we did when we started looking at this more seriously is let's speak to the climate scientists, let's speak to the meteorologists, let's speak to the OEMs, let's see what we can actually do today and to the ENSPs. Because if I just sit in my office and try to figure it out on my own, I will not be able to do this. So collaboration is super, super important. At IATA, we are doing this. We are speaking to all these people to try to figure out what it is that we can do. As I said, we're not climate scientists. We don't manufacture airplanes. We don't make fuel. We fly the airplanes. So as an organization that has 300 airline members and our members are flying all the time, how can we be a factor to help analyze this problem? And one of the things that we come up with is perhaps we can give more data. Perhaps we can put sensors on our aircraft that will measure humidity. This is already happening, by the way, but we can put more sensors on our aircraft that can measure humidity and can help the scientists to get the science straight. And this is one of the things that we are doing at the moment.
Yeah, I think it's really important to just emphasize that collaboration is just going to be so key going forward. And I think this nicely leads on to Stephen's question from last week, which was, do you see the prospects for a global solution to contrails and contrail avoidance and or coordinated regional approaches?
Yeah, thanks, Steve, for that. No,
you did say it was a difficult one.
Yeah. I mean,
see what you have to say.
Yeah, absolutely. I think that it's something that will grow over time, right? So I think that, and we're seeing it now, like local experiments have happened before. So over Germany, the Munich area did one in the US, and I think these experiments should continue. It's a bit easier to do it on a controlled airspace that's controlled by a state, for example, than we should collaborate, I know, but if we want to do it fast, we need to start with local, take the learnings from that, and then start doing like interregional trials for sure. Also, another thing we need to understand is that the contrails affect different states differently because they form at different latitudes, right? So they are a lot more common in the mid latitude, so over the US, over Europe, than they will be around the equator, for example. So whatever we think that we can do in Europe at the US might not necessarily be the same thing that they will do, on countries that are near the equator, because the likelihood of contrail formation is less. So it's sort of something that we need to also understand. But definitely, I think it's about looking for global solutions. Some of them might not be practical, if I'm honest. And these are kind of the things that we need to understand. The airspace is already very packed at the moment, right? And there are things that are closing airspace. So there are wars. There are military exercises, there's weather, there are areas where you have military bases and you cannot fly over them. So the airspace is already very patchy. There are already congestions and so on. Now, if on top of that we put the restriction of, okay, we will close this area because there is an ISSR there, which, by the way, we need to identify accurately, as I said, right? We close an area of the airspace, then we really need to be careful of evaluating the system-wide implications of that. Because now I'm not creating CO2 for one flight. I might be creating extra CO2 for a whole network. And that can be very, very damaging, So we need to be very, very careful that we are not jumping on solutions that will actually have a detrimental climate effect. Because remember, the end goal of everyone is to avoid the planet from getting above 1.5 degrees, and last year was 1.46 or something degrees, right? So we definitely want to be careful and not create any harm. So anyways, this question that yes, regional coordination is important, but we also need to assess how practical this will be and any potential consequences for that. Yeah.
Okay, I think what Stephen may respond to this could be potentially that the approach that they are taking is real time, and they are doing tactical deviations. And I think the unique point of their approach is that they are actually using observations, contrails that you see on satellite images already, and then you try to act on really short notice. Is that something, given the problems that you just laid out with regards to, you mentioned the uncertainties around the climate impact, but also the weather prediction. Is that something in light of this approach that is more promising then?
Um, to be honest, I don't know. I am familiar with their research, and I think it's great what they're doing. But again, they are experiments, and it has limitations too. So on one hand, we go back to the fact of blocking a whole airspace, because if you only divert one flight, but then 10 pass through there, then you create contrails anyway. So what was the point in deviating that flight? You have diminishing returns. There are things that we don't know still. So in an ISSR region, what is the water vapor on that? So the water vapor budget. So if I have one flight and create one contrail, then if I have 2-3 flights, am I going to create 2-3 contrails, or was all the water vapor condensed into that one contrail? We don't know that. We need to figure it out. So I think that these things are promising. They're good experiments, but they still have limitations. Then the other thing is the verification with satellites. I mean, very good because you can look at the image, but still differentiating a contrail cloud from a natural cirrus cloud is difficult, right? They can only perceive this after about 2 hours from the time the contrail has been created. So 2 hours after the cloud will grow, and then you can pick it with the image. Then you have to be able to match that cloud to a specific flight that flew 2 hours behind. Now, they are doing trials. Google did similar trials. It's not impossible, but at the moment it's still something that has to improve, so that we can make sure that that specific flight at that specific altitude created that specific contrail, and then we need to understand what the whole ecosystem around it looks like. Yeah,
it's really interesting that you mentioned the overlapping of aircraft exhaust plumes, because like that's literally my research area, is to see what we can do in terms of like exploiting those effects of, if there's a finite water budget in a certain region of the atmosphere, can we fly not just 1 or 2 aircraft through there, but what about if we fly 10 through there?
Yeah.
Surely those contrails will have diminishing returns in terms of their size and persistence, and probably resulting climate impact as well. And the same goes for NOx, because the more NOx you're putting into a region, the more that region becomes saturated, and therefore leads to less efficient ozone production. So I think, yes, it's important to state that it's a lot more nuanced than just saying, let's block a region because you might form a contrail. There's
exactly, yeah.
And not just from a scientific perspective, but like you were saying, also operationally as well. This is not something that a lot of air traffic managers would want to have on top of everything else that they have to deal with on a daily basis.
Yeah, and I think there's also, and I know I'm sort of highlighting on some of the challenges, but I don't want to sound like a pessimistic or a denialist. I'm not. I think that all of these experiments are good, and there are learnings that we are learning a lot from them, and we should continue to experiment, right? But I'm highlighting some of the learnings that we're having. But the other thing is that we don't understand is what is the counterfactual scenario. A little bit to your point. So we have an ISSR region that would form a cloud if the air was a little bit more full of particles, but it's too pure, it doesn't form the cloud. So we avoid flights going through there. And then what happens to that region later on? Does it dissipate? Will it form a cirrus cloud anyway? Just further down the line, will it be aircraft induced cirrus clouds that will get formed by the particles emissions of aircraft, but not directly flying through there, but that are still on the air? So all of these things we don't understand. So maybe we are avoiding this ISSR to avoid these contrails, blocking an airspace, creating more traffic, moving the aircraft to a region where they might create a contrail. We don't know that. And then cirrus clouds get forms anyway. We don't understand it. So I think that it's something that sounds very simple in practice, and we are exploring it. We do believe that we need to keep looking for these opportunities, but there's a lot of things we need to understand still.
Looking at this level of certainty or uncertainty that we're dealing with here right now, I'm just wondering, you mentioned that there are 4 or, round about 4 airlines that are actually trialing this. Is this enough at this point of certainty? Given we do have some certainty about this effect already, and I'm wondering, the number of 4 airlines sounds very little in light of how certain we already are with regards to the problem. How do you look at this? Shouldn't we be trialing this much more, or what is your outlook for 2024?
It depends on what certainty we're talking about. Some people would say 4 airlines is too much. because they would say, we cannot predict the ISSR regions so accurately today. So why are we moving flights around and failing? Like if you look at the results, the success rate is not terrible, but it's not great. We're talking success rates of maybe half of the diversions were successful, half were not. Some we don't know how to quantify. So we're kind of experimenting on things that are difficult to validate, difficult to experiment, perhaps emitting more CO2 emissions. So some people could argue that 4 is too many. Some people could argue and say, no, we need more, because the more experiments we do, the more we will learn. Okay, I think that is a valid point. But there are some things that we already know, and maybe more experiments might not give us more answers. So for example, the humidity field in the upper atmosphere. So what is the humidity levels? That is something that we are getting right now from satellite data, and it's not very accurate. So when you read papers, and this is not IATA's data, these are publications that are online. So Giren's, I think 2020, an MIT study in 2023, I believe, they looked at a comparison between satellite data and in situ measurements. They don't correlate, right? So you have very large errors in the humidity when you compare in situ measurements with satellite. So if we're using this as our entry point to detect where the ISSR regions are, and we're getting them wrong half of the time, then is it that the activity that we should be doing now, is it trying to avoid more and more and more, or is it trying to improve the humidity field so that then we can do more avoidance, so that then we can, I don't know, it's an open question, but I feel that it could be argued on both ways. Yeah.
Do you not think that the operational trials, or of course, I guess it's kind of in the name, but like most of the benefit that we get out of doing these trials is we're learning more about the operational feasibility of the concept, as opposed to proving the science or proving whether because we can use satellite data for that. That's something which doesn't require us to actually fly aircraft. It's something that we can do anyway based on pre-existing contrails.
Yeah, definitely on the operational side, we are learning a lot of things. So, I mean, I'm not saying we shouldn't do more. I'm saying we should keep doing it, but and we should keep learning and maybe learning different regions and so on. So there are a lot of things to be done. Maybe trying different fuel compositions, maybe, so and these things are happening, and we should continue for sure. So, but on the satellite comment, I do disagree. I do think we do need more measurements. The models that we have, the resolution that we have is not good enough to be able to do this operationally. Yeah.
Okay. So do you think, I mean, you mentioned it earlier about the increase in the number of sensors we have on aircraft. I don't know if you're familiar with the IARGOS project, in which
yes,
you've got a number of different A340 aircraft, which I think is for the last 20 years or so, 20 or 30 years, they've been operating these aircraft and taking measurements in flight at cruise altitude on humidity, chemistry, like the chemical composition. So do you think that there's a lot more scope for sensing to increase on aircraft in the next decade or so? Do you think that this is going to be a key area of progress?
Absolutely, yes. I mean, the IAGOS program has like 9 or 10 aircraft. Yeah. It's definitely not enough.
Okay.
A lot of what we know today about ISSR is through the IAGOS program. So we are forever grateful with the team for having done that. Some of the things I have quoted you now, an ISSR region is about 150 kilometers, plus minus 250. We know that thanks to IAGOS. The studies that have correlated satellite data to in situ measurements, thanks to IAGOS, right? So a lot of the things we know today about ISSR regions, contrail formation, and so on, are thanks to the IAGOS program. Now, 9 aircraft in the planet, taking humidity at altitude, definitely not enough. We need more. I don't think we need every single aircraft, definitely not, but we need just as much aircraft as we can to be able to improve the models, right? So we want to minimize the amount of sensors by maximizing the modeling output. We don't know what that number is, but some people believe it's in the order of magnitude of tenths per region, right? So 30, 40, 50 aircraft, in Europe, 20, 30, 40, North America, etc., etc. So we're not talking about hundreds or thousands. So this is a very sort of, finger in the air number, so don't take it as a rule, but we're still assessing that. But we believe that this is something that we need to be doing a lot more of, for sure.
20 to 30 aircraft doesn't sound like that much in the grand scheme of things.
I was wondering, you mentioned also efforts from IATA going on that try to gather more in situ data. Is this related to IAGOS, or are these different kinds of activities to increase the number of data available? As far as I know, IAGOS is open source data, right? And would this data that's being gathered within your initiative also be open source?
So we are talking to IAGOS, of course, and we're trying to figure out how this would work. So the idea is that the data will be given to the Met offices so that they can use that to improve their models, right? So it's not something that I mean, you can give me all the data, I don't know what to do with it. Like, we need to give it to the people that know what to do with it, right? So there are other examples. So the World Meteorological Organization with IATA have fitted sensors on aircraft. There's about 130 in the US, and there's a few others in Europe as well. And these sensors, they mainly take humidity readings at low altitude, so during takeoff and landing and descent. And the sensors are providing data today to the Met Office, and this data has been used to predict, thunderstorms, fog, heavy rain, etc. There's data being collected on winds, data being collected on pressure, and all this data has been used by the local Met offices for weather prediction. So we're not trying to reinvent the wheel here. We're trying to expand it and say, okay, can we capitalize on existing systems like IAGOS, like this, it's called AMDAR program from the WMO, but to put sensors that will be able to give us the readability that we need at altitude, and that can help us to predict ISSR regions better. And also, one of the main variables that affect the assessment of the climate impact of a contrail is the humidity, right? So getting more humidity data will not only help us to find where the contrails will be formed, it will also allow us to improve our prediction as to how warming or how cooling these contrails are. So it's sort of a win-win on both cases.
Yeah, gathering this data will definitely move forward all the efforts that are going on here. And yet we are engineers, we are used to deal with uncertainty, right? And we have to push all the buttons in parallel to get to more sustainable aviation, right? I'm wondering, moving a little bit the conversation to regulation, even though you've pointed out, the hesitations that there are still and the many open questions to be answered. But I was wondering, since you have such a good overview of the ecosystem, how you view, for example, the approach of the European Commission, who went out with a recent call in the Innovation Fund and actually stated, well, contrails are a problem and asked for solutions. Is this the right timing and the right approach at this point in time?
So the right approach to look for solutions, yes. I mean, there's never a there's never a bad time looking for solutions. Innovation projects or research projects are always welcome, and there are a few large projects in Europe. So definitely, I think that looking for solutions either operationally, technologically, fuel, engine technology, absolutely. Like we should be doing these kind of things. Yeah.
Okay, but still drilling down a little bit. I mean, of course, trying to find solutions is always good, but there's always opportunity cost. You've mentioned other initiatives in the beginning, right? Where the money could be spent on. So, do you still think that that this is something we should spend the money on right now, given all the uncertainties that you pointed out?
Well, if we don't do the research, we will not be able to reduce the uncertainties, right? So, I mean, I feel like we should be careful not to be. I mean, maybe distracted is a strong word, right? But diverted from the CO2, because imagine what a tragedy it would be if we suddenly divert more and more resources to non-CO2, and then we try to do this control thing, and then and then we do that at the expense of developing a hydrogen airplane, for example, right? I mean, when the hydrogen airplane could actually have a much more important environmental impact because we're getting rid of the CO2 emissions, right? Or stuff. So I don't think that we should, by 1 minute, sacrifice one for the other. I think our priority is CO2. CO2, we have the certainty. We have the certainty of how warming it is. We know how long it lasts in the atmosphere for. We know what the climate effect is. So we should definitely keep that as a priority. But I do believe that we need to progress on the science of the non-CO2 emissions as well.
Okay, we will progress on that regard. And this year is the year also when within the MRV, we want to come up with a way to actually quantify the non-CO2 effects, right? Given all these uncertainties that are still out there and the open questions, what is your level of confidence that we'll get to a good solution for quantifying those effects?
Right now, it's very low. If I'm honest, because I mean, I've just pointed out to some of the uncertainties, right? So some of the studies that I've mentioned say that using reanalysis data to quantify non-CO2 effects can lead to errors of 50%, 70%, 80%, right? So then when we are monitoring non-CO2 effects, what are we actually monitoring? What we are doing is we are using reanalysis data and aircraft trajectory to estimate what the non-CO2 impact is. But we know from publications, this is not IATA data, this is IATA data, this is peer-reviewed publications, that right now the data that we have is insufficient to be able to do this accurately. So what we'll be doing is we will be estimating some non-CO2 effects of flights. We will get it wrong, and then we will have a number. But what does this number mean? Is this actually very meaningful? And then when we try to quantify for the climate impact of this, the uncertainty on that climate impact is very large, right? So we know it's warming, we know like all of these things, we know there are things that we know, but there are other things that we don't know. And I mean, if you look at the recent literature, just global average sort of climate impact radiative forcing of contrails, some people say 8 milliwatts per square meter, some say 140, some say 60, some say 30. So which number of these are we going to take for an MRV? And then when you try to do this on individual flights, a recent study by Tio et al. Say like that uncertainty can be 200 times greater for individual flights. So we will come up with a number, we will estimate a number, and we will report it. But how meaningful is that number, and what are we going to do with that, right? So to me, the thing that we should prioritize now is definitely sort of help the science get it right. We can quantify a number, we can do it, and there are lots of publications there that have quantified global non-CO2 effects, but the uncertainty is just going to be so great that I don't know how meaningful it's going to be. Yeah.
You've mentioned Roger Tio just now, and this leads to our tradition of passing on the ball, because next week we're going to speak to Roger, and I'm putting you on the spot here, but maybe there's a question that you'd like us to pass on.
Yeah, I mean, maybe you can ask him about this thing I just mentioned, right? By the way, I really enjoy reading his papers, but you can ask him about the uncertainty of individual flights radiative forcing versus a whole fleet, and how this compares. Yeah,
that's a good one, Kieran. What do you think?
Yeah, I think that's a very fair question, especially due to the effects that you talked about earlier, where I mean, usually we're using large-scale models to capture global climate impact of contrails, but when it comes to an individual flight, you have to really model these subgrid scale processes. So
exactly. Yeah.
The presence of existing ice clouds, the impact they have on the water vapor budget in that subgrid scale area, and the implications that will have for the formation of contrails, the persistence of contrails, and the climate impact of contrails.
That's right. Yeah.
Earlier, we've mentioned you've mentioned a paper that I'm looking at right now. We will link it in the show notes. I think for the listeners also quite interesting. It's from IATA about non-CO2 aviation emissions and the standpoint. And I think this would be a nice follow-up reading. So we'll put it in the show notes. My last question to you would be, what do you see will happen in this year, 2024, with regards to contrail management? Is there any kind of event you're looking forward to, or is there any kind of experiment you're looking forward to?
Um, that's a good question. There are many things happening. So I know of some initiatives that are assessing the potential non-CO2 effects of using SAF, different SAF blends. This has been researched, before, but the results are inconclusive. Some results say that it can be better, some it's the same, some a bit worse. So I know there's more flight campaigns this year. I really want to see what happens there. Uh, Airbus is conducting some studies as well. I think the project is called Condor. They're flying a glider with a hydrogen gas turbine, and they're putting the water vapor there and trying to analyze the non-CO2 effects of that. That's going to be very interesting to know. Some of the airlines are continuing doing the trials. So also we want to learn more about their experience operationally, as you said, Kieran. Were they able to do the tactical avoidance every time? Were they not? Were they able to verify? I think right now one of the big keys on these diversion procedures is verification. How do we actually verify that we've been successful? It's challenging, right? So and there are a couple of events. So ICAO will have a conference on non-CO2 at the end of July, I believe. So that should be quite interesting. And we at IATA are hoping to also do another publication on this topic, mainly speaking about the work that we have been doing, part of the sensor, some of the things we have spoken about here. So that's going to be exciting too.
Alejandro, this has been great. This has been a very sharp discussion, very to the point, and you have laid out your opinions very clearly. So thanks a lot for that. And like I said, we'll link this one paper in the show notes. Hopefully, we see you again in Miami.
Yeah, excellent.
Later this year.
Yeah.
But big thanks from my side.
No, thank you, Marius. It's been a really interesting discussion. Thank you, Kieran, as well. And hopefully we can catch up in Miami.
Yeah, really enjoyed it. Thanks a lot, Alejandro.
Thanks a lot.
Thank you.
Bye-bye.
Maybe see you soon.